Hi, and in today's video, we are gonna go over stoichiometry. I told Jeff not to give me any chemistry related topics. And he didn't listen to me, so I'm gonna have to give him a call. I gotta call him. I gotta call him. I gotta call him. Let's see, what's his number? I don't know. Okay, let's see. Okay. Yep. Hi, John. I'm at Jeff. Yeah. So, why'd you give me this stoichiometry video for today? Yeah? Uh-huh. Yeah. Yeah. You know your paycheck? Gone. Okay. Okay, anyways. Okay, we're gonna learn about balancing chemical equations. Feel like we already did that, so I don't know what Jeff is saying. We also gotta understand mole ratios. Convert between grams and moles, and limiting reactants, and percent yield. And I'm sure this would be very fun. So we got a lot of slides to go through. Okay, so a law I need to teach you is the conservation of mass. And you need to understand that matter is neither created or destroyed. And the number of atoms of each element must be identical on both sides of the reaction. See? They don't have to be, it can be like, it doesn't have to be all one mass, but it still just has to be the same mass on this side and that side. And you're gonna learn, I don't think in this video you're gonna learn about one step stoichiometry equations, but when I was in chemistry, you had to learn 2-step, 3-step, 4-step, 5-step, 6, 7, 6. Okay, so I think we already went over this, but in another video, but we're gonna just go over it one more time about balancing equations. So you never want to balance the subscript, but actually the coefficient in front of it. And right here, you have to put a number in front of here, in front of here, in front of here to balance it. And this would be your final balance equation. I'm not gonna go over it, but you should know this. I'm gonna give it. I think should after every exam, after every month, should I give a final exam? Ho, did you see like those videos where professors told the students either write a 20,000 page essay or I don't know, do something for 15 seconds in front of the class, I think? I forgot. Should I be one of those teachers? I don't know. Okay, so a stoichiometry roadmap. Jeff has some clever ideas. We're gonna. I'll let you look at it for a second to see if you understand because Jeff, he. Is it Jeff? I forgot already. Jerry, Jeff. It's hard. Yep, okay, so we're gonna go into understanding mole ratios. So the coefficient in a balanced equation provides the conversion factor between substances. So the possible mole ratios for NH3 and the H2 is at 2 moles divided by 3 moles or 3 moles divided by 2. So this is say how many moles here. So mole is like just like a unit as to say, right? And I think stoichiometry wants to understand how many moles do you have to provide here to get this amount of moles. And what you want to first off do is always put the unit you want on top. So if you want moles, you put on top. And always put the unit you are starting with on the bottom to cancel it out. Because you want to get to, if you're trying to convert to another unit, you want to cancel out the first unit so you can get to the second unit. It's bringing me back to my chemistry days. Okay, so calculating the molar mass. So, one atom. So let's say you have one atom of carbon. that's around 12.01 grams per mole, right? And something like avocado's number 6.63 times something. That's how much is in avocado's number. But CO2, it has a molar mass of 40.01 grams per mole. It's not grams, it's grams per mole. So don't forget to put that. Okay, so a checklist. First off, you want to balance the equation because if you don't do that, you can't do anything. And then you want to convert the given mass, grams, into moles using the molar mass with your chemistry reference table. I hope you have a chemistry reference table. Oh, I'm kind of hungry, so I'm gonna eat some of this really quick. Mm-hmm. Mm. Mm-hmm. Mm-hmm. Mm. Mm. I'm not getting off topic, right? Okay. Then plot a mole ratio, and then convert back to grams if needed. Okay. I think it's better if you get a practice problem to see instead of just me telling. So, okay. So the reactants are C3H8, 5O2, 3CO2, and 4H2O. If you burn 44.1 grams of propane, which is the C3H8, how many grams of carbon dioxide will be produced? And the useful data, I guess you don't need your reference table, is that C3H8 is 44.1 grams per molar, and CO2 is equal to 44.0 grams per mole. So pause the video and just write it down on a piece of paper, or do it in your head if you're like Sheldon from that show. Everyone said to watch it, but I literally never watched it. I never saw the appeal of it. I just watch it on TikTok sometimes, you know. Okay, I'll give you like a minute to solve it. Let's see. Time to. Oh, shoot. Hold up. I'll be right back. And I am back. Don't mind where I went, but I hope you solved this. And the answer is step 1, you have to convert the grams into moles. So since you have 1 mole per 41, you have exactly 1 mole. And then you use the mole ratio, 1 over 3. 1 times 3 over 1. That gives you 3, and then you convert back to grams, and that's 132. So this is like a really simple one since you didn't have to like really convert that much, as you already had just 1 mole, so you didn't really have to do much. But let's go into limiting plus excess reactant. So the limiting reactant is the substance that is completely consumed first. Oh, I remember this. Oh, yeah. Yeah, it's the maximum. So that will determine the amount of stuff that can be produced. And if you want a real world example, so think about, okay, pretend you're Gordon Ramsay, right? You're making a sandwich, but you only have 10 slices of bread, but only 2 slices of cheese, and you want to make a grilled cheese. How many grilled cheeses could you make? Whoever said 10, I heard you, okay? But you can only make 2, so the limiting reactant will be the cheese. Okay, so let's go into a problem. Let's say you have 2 moles of N2, which is nitrogen, and 3 moles of hydrogen, H2. Which is the limiting reactant? Okay, you have to first calculate how much NH3 each reactant could produce. And the one that produces less is limiting. So you got to calculate the theoretical yield for both N2 and H2. I think Jeff learned it a different way because I think I learned it like whichever runs out first is the one that is the limiting. I don't know. This was a long time ago, and I didn't pay attention in that class. So okay, I'm gonna give you another minute. Hmm. Let's see. Okay, so let's see if you solved it. So the solution is you have to first find out from N2. So 2 times 2 over 1, you get 4. But from hydrogen, you get 3 times 2 over 3, and that's 2. So as you can see, H2 is the limiting reactant because it produces a smaller amount of NH3, which is only 2 moles. So I think that is one way to do it. And then if you get it wrong on your chemistry exam, good. I just blame Jeff. We can all blame Jeff. Okay. So the theoretical versus percent yield. So that's the theoretical is the maximum amount of product calculated using stoichiometry, and the actual yield is the amount of product that was actually observed in a lab. So percent yield is actual divided by theoretical times 100. Example, if you could calculate that you could make 50 grams but only made 45, what is the yield? And that's 90%. Personally, in my high school chemistry class, I did not have to do yield. I just did like percent errors and stuff. So I learned something too. Oh, my thing's all messed up again. Jeff is really gonna. Okay, but it's everything you already you should know. And just balance it. Just balance the equation. Always convert to moles to compare chemicals, and then use the molar mass to go between grams and moles, and then the limiting reactant is always the one that produces less product. And then one AP exam tip is show every step of your dimensional analysis. Always show your work, show your work, show your work, show your work. I sound like a teacher, bro. I sound like a teacher right now, but am I? I don't know. But just make sure to show your work, and it will help you reduce your errors. And I hope you learned something. And can we tell Jeff to stop giving me chemistry? Like, I swear, if this is my most popular video type, chemistry videos, I'm cooked. But I'll see you in another video. Bye.